taking a look at our periodic table and just understanding a few things from it. Our periodic table looks something like this. If you're looking at the Nelson Chemistry Alberta 2030 periodic table that I've posted on our homepage, this is the one you want to use for our class because it's the one I reference and has all the values that we would be using. This one is just one I pulled off of the internet to fill in a gap here. Okay, so we're just going to quickly label the table with the following groups, periods, halogens, alkaline earth metals, noble gases, alkali metals, metals, transition metals, and nonmetals. All right, first up, let's label groups and periods. Groups describe the column of elements all the way across. So this would be group 1, group 2, this is group 3, etc., 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 all the way to the end, and this is group 18. Okay, so groups are the columns. Periods, I guess I should do this. Periods are the rows across, so this is period 1. Period 1 contains 2 elements, just hydrogen and helium. Period 2, and so on and so forth, all the way down. Sorry, I don't want to confuse us. I'll get rid of that arrow. So periods are the rows across. Where do we find the halogens? So the halogens are this group here. The halogens are group 17. What am I up to here? Okay, so the halogens are group 17. They have a bunch of things in common, like their charge and a lot of properties. The alkaline earth metals. All right, the alkaline earth metals are the second group. So the alkaline earth metals are group 2. I always have to look up who's who when it comes to alkaline earth and alkali. Sorry. We don't talk about them that way a lot. I'll just say group 1 or group 2 usually. Okay, they share a lot of properties. They're very reactive. Not quite as reactive though as, let's skip ahead to the alkali metals. Alkali metals are very reactive. These guys are group 1. Now, technically, we have hydrogen in group 1, but it is not a metal. We'll get to that. So the alkali metals are from lithium onwards. So except hydrogen. The noble gases, are group 18, the one I was trying to circle earlier inadvertently. And these guys are not very reactive because they have full octets. Okay, the metals. Metals make up the majority of our periodic table. So we may want to talk about the staircase quickly first. The staircase on our periodic table goes something like this. Okay, sometimes you'll see staircases ever so slightly different, but that's okay. Around the staircase are some transition metals. We don't really talk about those guys too much, but I guess, metalloids, my mistake, not transition metals. So I'll color them in just like they are on our periodic table. On ours, they are purple. I don't get to choose that, I don't think. That's okay. Yes, I can. All right, so boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and astatine are all metalloids. And these guys share properties of both metals and nonmetals. Typically, they conduct electricity, but they are not very hard or lustrous. Okay, the metals in our periodic table are green. So in our periodic table, that would mean all of these guys are metals, all the way up to our metalloids, and the entirety of our lanthanides and actinides, these guys down below. So our metals were this color. Our non-metals are like an orangey yellow, and that's all of these guys. And we could include all of our noble gases. They get colored a little bit differently, but they are considered a non-metal. And don't forget hydrogen. It's really important that we don't forget hydrogen is actually a non-metal. All right, last but not least, let's just talk quickly about transition metals. Where do we find these guys? The transition metals are actually in the middle. Okay, it's this block that makes up group 3 through 12. These guys have some very different properties. Oftentimes, they have different charges in their column or in their group. They don't follow that kind of rule where we know oxygen, sulfur, selenium, they all have the same charge. We know that fluorine, chlorine, bromine, iodine, they all have the same charge. But if we work down a column in the transition metals, they don't have that same. A lot of times their properties aren't identical. They're somewhat similar, like sometimes they can be magnetic and others aren't. They have multiple charges. They're kind of tricky. And then below are the lanthanides and actinides, and we really don't talk about these very much. I might use them in a couple of examples for naming, but we don't see them very often. All right. So some information from the elements. If you look at our periodic table, it looks a little bit different than this element, but we can read the key up at the top for iron. Okay, noting that the big number on our periodic table is the atomic number. Right below it is the electronegativity. The most common ion charge is listed first, and any other ion charges are listed below. The symbol is the largest thing you see, the name of the element, and the atomic mass or molar mass. Okay, this one looks slightly different for vanadium. So the atomic number for vanadium is 23. It's that large number in the corner. We could use our periodic table to help us discern this. The atomic mass for vanadium is 50.94. Now this has units. We need to write grams per mole. Okay, so don't forget units with atomic mass. The most common charge for vanadium in this case is listed always first in some way, shape, or form. So 5 plus. The number of protons in vanadium is equal to the atomic number, 23. The total number of electrons has to balance the total number of protons because protons are positive, electrons are negative, and an element is neutral. So if there's 23 positives, there's got to be 23 negatives. Where is vanadium located in our periodic table? We just kind of talked about it. Vanadium is in the transition metals. You could have also said group 5, but it was looking for that transition metal piece. Make sure you're familiar finding all of this information in your periodic table.